Hey everyone, and welcome to today's lesson about combining exponential equations. The goal of today is to be able to combine exponential equations using our four operations: addition, subtraction, multiplication, and division. Looking down into the lesson, we see that we can perform operations on functions just as you can numbers. So in the box you see a little bit of the notation. If I see f plus g of x, that means I'm going to do the function f of x plus the function g of x. It works similarly for subtraction, multiplication, and division. Let's go ahead and look at example number 1. Oh, that was the bell, but you can't go anywhere. Let's look at example number 1. And we're going to find the sum or the difference of the functions given. So in the first example, in A, I have the function f of x equals 5x minus 7, and I've got g of x equal to negative 2x plus 1. So the first step is to add f plus g of x. Well, we know from the table above that that's the same thing as doing f of x plus g of x. I can see that f of x is 5x minus 7, and g of x is negative 2x plus 1. I'm going to put that one in parentheses, just so we can clearly see which two functions I'm adding together. Now, when I'm adding, I need to find my like terms. So I can see that 5x and negative 2x are like terms. So I can add those together and I get 3x. And then I notice that negative 7 and 1 are like terms. So negative 7 plus 1 is negative 6. All right, the next job is to then evaluate my new function at negative 3. So I'm going to plug in negative 3 for x. Let's do that right over here. So if I do negative 3 times 3 and then minus 6, I get negative 9 minus 6. Excuse my bad handwriting there. And I get negative 15. Let's try one with subtraction, and you'll notice that I have two exponential functions now. I know they're exponentials because I have my variable being x. All right, f minus g of x is f of x minus g of x. And I see that f of x is 4 times 3 to the x, and g of x is 3 to the x plus 2. So I'm going to go minus 3 to the x plus 2. All right, and rewriting this, I see that the negative sign has to go to both 3 to the x and to 2. So I'm left with 4 times 3 to the x minus 3 to the x minus 2. Again, that negative sign gets distributed. All right, this is where it gets a little bit tricky. This is where we need to realize that 4 times 3 to the x is a little bit like 4x, because I have 4 3 to the x's, and I'm taking one of those 3 to the x's away. So this is a little bit like 4x minus x, which we know is 3x. So in this question, 4 times 3 to the x minus 3 to the x is 3 times 3 to the x. I'm taking one of those 3 to the x's away, and then again it's still minus 2. All right, so that's what I get when I subtract my functions. Now I'm going to evaluate at 2. So I'm going to plug in 2 for x. I'm going to change colors so we can see I'm doing something different here. This is going to be 3 times 3 to the second power minus 2. I have to follow my order of operations, so this is 3 times 9 minus 2, which is 27 minus 2, and that equals 25. All right, moving right along to multiplication and division. Okay, same idea. F times g of x is f of x times g of x. We are given that f of x is 2 times 5 to the x, and g of x is 3 times 5 to the x. All right, since I can multiply in any order, I'm going to rearrange things a little bit. That way I have my constants being multiplied and then my powers being multiplied. So I've got 2 times 3 times 5 to the x times 5 to the x. We all know that 2 times 3 is 6. Now I look over here at 5 to the x. This again gets a little bit tricky. If I am multiplying my two powers with the same base, I add my exponents. So 5 to the x times 5 to the x becomes 5 to the 2x, because x plus x equals 2x. So this is what I get when I multiply my two functions. Now I have to evaluate at -1. So I'm going to plug in -1 for x. Again, I'm going to change colors for you. So I have 6 times 5 to the second power times -1, which equals 6 times 5 to the -2 power. The negative exponent has to go to the bottom, so I've got 6 times 1 over 5 squared, which is 6 over 25 as my final answer. I go back to this is the key part here, that 5 to the x times 5 to the x is equal to 5 to the 2x. I'm adding those exponents when I have the same base. All right, looking at B, I've got some division going on. So I'm going to be dividing my two functions. So this is f of x divided by g of x. F of x is 4x plus 3, and g of x is 2x minus 7. I cannot do any further division there, so I'm going to go ahead and evaluate for when x equals 12. So 4 times 12 plus 3 divided by 2 times 12 minus 7 equals 48 plus 3 divided by 24 minus 7. I'm left with 51 over 17, which is equal to 3. All right, let's flip to the back. We'll try an application question, and then it'll be your turn. All right, talking about a little wildlife. I've got a biologist studying the deer population in 2 state parks. She models both parks with a function. So the population in Park A after x years is modeled by the function a of x equals 200 plus 25x, and the population in Park B in x years will be modeled by b of x equals 100 times 1.05 to the x plus 40. What is the function giving the projection for the total population of deer in both state parks? So if we're talking about total population, that's going to be Park A plus Park B, which is a to the x, a of x plus b of x. I'm going to go ahead and add those two functions together. So that's 200 plus 25x plus 100 times 1.05 to the x plus 40. From here, since I'm only adding my like terms. 200 and 40 are like terms. Those are the only two I can add together. So I'm left with the function 100 times 1.05 to the x plus 25x plus 240. The last step is that it wants me to then predict the population in 4 years. Since x represents years, I'm going to plug in 4. I'll do just that. And then I can use my trusty calculator to calculate the actual population. Once I'm done plugging in 4, I plug all that into my calculator. I'm left with approximately 462 deer. All right, now it's your turn. I want you to try the self-quiz and then check your answers. All right, on the self-quiz, for question number 1, when you combine your functions, okay, when I do f of x minus g of x, I should be left with 3 times 5 to the x minus 2. And when I plug in 5, I should be left with 9,373. For question number 2, when I multiply my two functions, I should be left with 35 times 2 to the 2x. Remember, I add those exponents. And then when I plug in negative 2, I should be left with 35 over 16. In question number 3, dividing my functions, I should have 4 minus 3x over 3 minus 4x. And then when I plug in 4, I should get 8 over 13. Last question, when I subtract my two models here, because I'm looking at the difference in the number of steps, when I do the subtraction, a of x minus b of x should be equal to x. So that means there will be 10 more stairs in Model A than in Model B. What I'd like you to do is grade your self-quiz. Please give me the number out of 4 that you got correct the first time around, and then go back and check and try to fix your work to get the correct answers for the self-quiz. Come to class tomorrow ready to report your score. Hope you learned a lot, and that's all for now.